Hey everyone, today I bring to you another progress video on the project. With each next video and each next feature being implemented into the game, the videos are becoming less and less about any specific feature and more about the overall state of progress. And this is actually a very good thing. It means more and more aspects of the game are getting finalized, which brings us all closer to a day when the project will be completed and released. But of course, my original estimate of 3 to 4 years still stands, mainly due to insane amount of content that needs to be made. Today is one of the transitional videos, in a sense that it's still mostly about one major feature, but it will also showcase some other independent features and improvements. In particular, today's video will showcase the new menus, the settings menu family, which consists of audio, graphics, gameplay, and input, as well as the secret cheats menu I've talked about in the previous videos. As for the new features, we also have 2 major incoming ones. First, there's a dual localization for Digimon and move names, and then there's a game transition from deferred to forward renderer. Coming next, there are some new Digimon abilities implemented, and finally, some small bug fixes and overall stability updates will be discussed. Alright, let's talk about the menus first. Settings menus look like something that would typically be done as a last thing compared to other menus. But because some of the features that are currently being either implemented or tested need the settings to be configurable, and because the framework has been long implemented to finally make these menus, I've decided to do them now and forget about them. The original game never had any settings to begin with, so I had to come up with a design that would fulfill its role while also fitting into the game's user interface style. The way I've approached this is that the core settings menu is always accessible from the in-game main menu, and from it, player can access other submenus. First, let's look at the audio settings. The game has several groups of sounds: background music, sound effects, Digimon voices, and lastly, UI sounds. The classic approach to this configuration is to have a separate volume slider for each group, as well as the master slider that controls the overall volume. Here's what it looks like. Going further, it's time for graphic settings. Modern games tend to have ungodly amount of sliders for controlling different aspects of the rendering process. In contrast, here I've implemented very simple menu. You can toggle between windowed and full screen modes, which also can be done using Alt+ and a keyboard shortcut. For the windowed mode, you can change the window size. The resolutions in the list are all 16:9 ratio, which is the optimal screen ratio recommended to play this game. This, however, does not mean the game is unplayable with any other screen ratio. In fact, by turning the full screen mode, the window will be stretched to the current screen size, be it 4:3 or 21:9, or anything else imaginable. The menus will also reflect this properly. Maximum window size is 8K, as anything larger than that is simply pointless. For full screen mode, there's also a VSync toggle. Normally it should always stay on, but the ability to turn it off may be useful to people that play on monitors or TVs with non-standard or strange refresh rates. Next, FPS limit can be configured. By default, the game will run in 60 FPS mode, but a wide range of different values can be used instead, including the uncapped mode, which is the last value. Uncapped mode can be used as a benchmark tool, as well as a bragging rights token to showcase the power of your GPU. Next up is the resolution scale multiplier, which is another feature that can help bring FPS up if your machine struggles with rendering. Note that this is not related to super resolution technology by any means. This is a native Unreal Engine feature. By default, the game will render with a full resolution, which is 100%. The value can only be lower from this value, down to 25% minimum. For the most part, this one does not need to be changed. And coming last, there's a render quality level. Yet another way to perform trade-offs between performance and quality of render. There are 5 levels of quality that can be used, which mirror the presets provided by Unreal Engine out of the box. For the mid-level machines, high preset is actually a fully viable setup, which is also the default value. Note, however, that for the reasons explained later in the video, even max level is still enough to pull off a perfect 60 FPS smooth rendering. Coming next, we have gameplay settings. This menu contains the player-related settings that control various game mechanics. Let's discuss game difficulty first. There are 2 possible settings here, casual and original. Original makes most aspects of the game work like they did in the original game. Targeting preemptively defeated targets will result in a miss. Losing a battle will result in instant game over, enemy HP and MP will never be displayed, and so on. In contrast, casual mode allows a more lenient gameplay to take place and contains collection of improvements over the original game's gameplay mechanics that are generally meant to reduce the grindiness and boringness in the game. Digimon Names is one of the new features I've talked about in the beginning of the video. It allows to switch between the original Japanese localization and the US dub one for both Digimon and moves names. For instance, Myotismon is a dub name, which is originally known as Vamdemon. Most of the Digimon and moves have completely separate names in original and dub modes. Next up are the settings, which are also accessible from the game itself using shortcuts, but are duplicated here for convenience. Battle speed multiplier and dungeon map mode. Battle speed can also be manipulated during active battle phase, using directional buttons, and map mode can cycle through using select action when in dungeons. Now it's time for the input menu. The game has 9 different input bindings, 6 of which can be changed to match players' preference. Navigation, camera orientation, and brakes are special bindings that cannot be changed. On the other hand, they include the most typical setups used by players in other games. The reason why they are visible in the menu is so that player can see what buttons they are bound to for reference. Finally, let's see what Cheat's menu has to offer. It contains all of the flags that were previously set to the editor interface in previous videos. It is also one of the menus that can potentially be expanded if any new cheats are implemented. As I've originally mentioned in one of the previous videos, Cheat's menu is originally hidden and inaccessible. In order to reveal it, you need to perform a Konami input code while in pause menu, which will then play a unique sound, signifying the cheats being unlocked. After this, cheat submenu can be found in settings. All settings except cheats are saved to a dedicated file, independent of the player saves. Save process occurs automatically upon any changes being made from any settings menu. On the other hand, cheats only stay enabled until the game is closed and have to be re-enabled again after it's restarted. That's all for menus. And considering one of the new features was already explained during a gameplay settings showcase, it's time to discuss the other one, the the forward render transition. Unlike dual localization, this one is purely a technical feature. Basically, what it means is that I've completely disabled Unreal's default deferred renderer, which is responsible for its vast but also very costly visual features. To spare you all from a full technical coverage of the topic, I will simply say that after an intense analysis, I've come to the conclusion that I don't need the features provided by the default renderer, especially considering the cost at which this all is provided. As a result, using forward renderer puts many limitations on the engine when it comes to post-processing features and things like advanced lighting, but considering this game never needed those in the first place, all these features can be safely ignored. The only real downside for Project is the inability to transfer the X-ray effect as a forward shading technique, due to relying on extensive post-process features of the deferred renderer. For now, I can't say if this issue is temporary or permanent, but even if it's permanently lost, I think most people would agree with me that it's a fairly minor loss. It's the other side of things when the real fun begins. Essentially, turning forward shading on single-handedly solved a huge load of issues related to performance and controversial things like AI enhancement and upscaling. Believe it or not, I got 120 plus FPS performance on max quality level on my Asus ROG Ally and my 10-year-old Windows 10 PC, which can't even run Windows 11. Now here's the kicker. That's the debug version of the game, which is heavily unoptimized. Now I can't state the exact gain on the release version compared to the debug one, because I haven't built the release version yet, but rough estimation suggests about 200 plus FPS in the future release build on the very same devices I've tested the debug version on. Shocking, right? Especially considering all the controversy related to the latest generation GPUs and their AI usage to fake the performance, like DLSS and FSR technologies. So far, before switching to forward renderer, I used to have around 80 FPS on a high-end laptop with Intel i9 and GeForce 4090. And that's on high quality settings, which is 2 levels down from max, which gave 50 to 60 FPS. And then, just from the switch to forward renderer, I was able to get 240 FPS with ultra settings, which I personally consider a huge victory. Now, you could easily point out that the game is not completed yet, so it's no wonder we currently have high FPS values. But it's an incorrect assumption, because current iteration of the game already bears most of the load of visuals to be used by the final iteration. At this point, it's just a matter of adding minor props to overworld and dungeons. Everything else is already done. Alright, that's it for the new features. Now, let's take a look at more minor changes. First, we have some new Digimon Abilities. To be more precise, a family of abilities that work the same way, but have different elemental properties. They are Void Efficient, Pyro Efficient, Hydro Efficient, Terra Efficient, Metal Efficient, Lumo Efficient, and Umbra Efficient. Each of these abilities provides half MP cost cut for the moves of matching element, while doubling the cost of the moves of all other elements. The Digimon currently assigned to these abilities are temporary for testing purposes, and will most probably be changed going further. Finally, the minor fix I've mentioned is related to Digimon Evolution's list menu. Until now, Digimon's identity name in the top right corner was not being updated after going back to menu from the evolution sequence. Now it's properly updated. Also, as you can see, evolution sequence can now be mostly skipped by pressing start when it begins. A little trick to speed things up for players that constantly transition between different evolutions on the same Digimon. So here it is, the state of the project as of now. In a few next videos, I'll be covering the rest of the dungeon features like traps and treasure chests, as well as gradually adding new Digimon and characters. There also are some of the menus that are still unimplemented, like shop menus, Fusion Lab menu, mechanic menus, and Digimon Trade menu. Those will also be addressed in later videos, though the Digimon Trade, as a feature in general, will most probably be deferred until after the end of year demo, as I plan to focus on higher priority features for the demo. Your likes, comments, and subscription is highly appreciated, as it will help to spread the news about the project far and wide. Thanks for watching, and have a great day. MLP out.